In this video, you will learn the parts of an exponential expression, as well as how to translate from exponential form to standard form. So let's begin by explaining what exponents mean. So for example, if we had 2 times 2 times 2 times 2 times 2. First off, the numbers we're multiplying are called factors. So each number is a factor. Now, what we can do is we can write this multiplication problem by using exponents. So exponents are used when you have the same number multiplied over and over again. So the way we can write this is we take the factor of 2, and we write that as this bottom part we see right here in green, and then the number of times we multiply it together we write here as our exponent, which is the 5 in this case. So this means we have 5 2's multiplied together. So this 2 is called the base, and the 5 is the exponent. And in English, the way we would say this is 2 to the 5th power. So we're going to explain how to translate back and forth between factored form and exponential form. So over here, factored form would be when you have the numbers multiplied together. So 3 times 3 times 3 times 3, for example, is factored form. Now in exponential form, we write this with exponents. So 3 is the factor that's repeated, so 3 is going to be the base, and then your exponent is 4 because we have 4 3's multiplied together. So this would be written in exponential form right here with a 3 and a little 4 up here above it. So this in English would be stated as 3 to the 4th power. Another example, we have 6 times 6 times 6. This is factored form, and then to write in exponential form, we can write this as a 6, and then with an exponent of 3, so we write it like this. So 3 is our exponent because we have 3 6's multiplied together. So in English, we would say 6 to the 3rd power. Okay, now make sure you know how to go back the other way as well. So if you're given something in exponential form, know how to write in factored form. So for example, if we had 5 to the 2nd power, we can write this as 5 times 5 because we have 2 5's multiplied together. Here we have 4 to the 3rd power. This means we have 3 4's multiplied together. So we have 4 times 4 times 4. So make sure you know how to translate from factored form into exponential form, as well as from exponential form into factored form. Now we have some special names that we give to anything that is raised to the 2nd power or to the 3rd power. So here, for example, if we had 4 times 4, this is 4 to the 2nd power. A special name we give to this is we can state this as 4 squared. So anything to the 2nd power is going to be squared. That's another name we can give to that. And where this comes from is from geometry, where to find an area of a square, for example, if the square is 4 by 4, to find the area, we would do base times height, or 4 times 4. So that's where it comes from, is because that is how we get the area of a square, so it's called squared. Now if you have something to the 3rd power, such as 4 to the 3rd power, the special name we give to this would be 4 cubed. So anything to the 3rd power we can state as being cubed. And where this comes from is from finding the volume of a cube in geometry. Because to find the volume of this cube, if every side is 4, we take the area of the bottom, so 4 times 4, and then multiply that by the height of the cube, so times another 4. So 3 4's multiplied together is how you find the area of that cube. So thus the name 4 cubed. Now here we have a pattern that I want to point out to you. So let's take 2 to the 5th power, for example. 2 to the 5th power means we have 2 times 2 times 2 times 2 times 2. And if you do that, you get 32 as an answer. 2 to the 4th power would be 4 2's multiplied, so 2 times 2 times 2 times 2, which is 16. 2 to the 3rd power would be 2 times 2 times 2, which would be 8. 2 squared would be 2 times 2, which is 4. So keeping this pattern going, okay, notice on the right side. The pattern on the right side is each time we're dividing by 2. Right? 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. Okay, so keeping the pattern going, if we divide by 2 again, 4 divided by 2 would be 2 on the right side. That would be a 2. And on the left side, notice the exponents. We have 5, 4, 3, 2. So the next one would be 2 to the first power. So 2 to the first power would equal 2. So it equals 2 because the pattern each time is we're dividing by 2. 4 divided by 2 gives us 2. So anything to the first power does not change the original number. So I can have like 100 to the first power. That would just be 100. 10 to the first power is just 10, and etc. Now, keeping the pattern going further. On the left side, the exponents are decreasing by 1. So 5, 4, 3, 2, 1. Next would be 2 to the 0 power. Keeping the pattern going on the right side. Each time we're dividing by 2. So here we take 2 divided by 2, and that gives 1. So notice that 2 to the 0 power is equal to 1. And we find that anything to the 0 power will always equal 1. So we could have 3,267 to the 0 power. That would still equal 1. I could even have this really complicated looking thing. Okay, this is algebra. And raise that to the 0 power, and it's still 1. It doesn't matter how complicated the thing is that we're raising to the 0 power, it will always equal 1. Alright, now let's keep the pattern going even further. So on the left side, the exponents are decreasing by 1. Right, so 2, 1, 0. The next exponent would be negative 1. So there is such a thing as a negative exponent. And notice what that would equal. Keeping the pattern going on the right side, we take the 1, divide by 2. That gives 1 over 2. So what we have is this negative exponent means that we have a fraction. So this is 1 over 2. Or you can think of this as 1 over 2 to the first power. And again, keeping the pattern going further, the next exponent would be 2 to the negative second power. And keeping the pattern going on the right side, we have to divide by 2 again. So 1/2 divided by 2, we would find that to be 1/4. Or we can think of that as 1 over 4 is 2 times 2, or 2 squared. So we have 1 over 2 squared. Now at this point in 6th grade math, it's not very crucial to have a firm foundation in negative exponents, but it's worth pointing out that there is such a thing, and what it means is that we have a fraction, as we see over here. All right. So next we're going to get some practice with writing with exponents. So here we have 4 times 4 times 4 times 4 times 4 times 4. I think I said enough 4s. There's 6 of them regardless. And you're to write this with exponents. What you do is the base is 4. And you write this as 4 to the, that should be a 6. So 4 to the 6th power, because there are 6 4s multiplied together. Here's another example where we have 1, 2, 3, 4, 5, 6, 7, 8. 8 7s multiplied together. And remember, the parentheses next or around the numbers means multiplication. So we have 8 7s multiplied together. This would be written as 7 to the 8th power. Okay, the base is 7, and 8 is the number of 7s we have, so 7 to the 8th power. Next we have 8 times 8 times 8 times 8. So we have 4 8s, so we can write this as 8 to the 4th power. And by the way, notice the different ways of writing multiplication. We can use the raised dot, parentheses, or the multiplication sign. Okay, next we have a fraction, 1 over 3 times 3 times 3 times 3. Okay, this with exponents would be 1 over and then 3 to the 4th power. So you can keep it like this. If you want to get fancy and write this with negative exponents, remember fractions means negative exponents. So I could write this as 3 to the negative fourth power. That is the same thing. Another example, we have 1 over 2 times 2 times 2. So there are 3 2's multiplied together in the bottom. So the bottom we can write as 2 to the third power. So we have 1 over 2 to the third power. And again, if you want to write this in with negative exponents, you can write this as 2 to the negative third power, because fractions mean that we have negative exponents. Next we have 1 over, and then we have 3, 4, we have 6 5's multiplied together. So the 6 5's you can write as 5 to the 6th power. So we have 1 over 5 to the 6th power. And then we can write this without the fraction as a negative exponent, and that would be 5 to the negative 6th power. Okay, next we have a term called variables. So variables is simply a letter used to represent an unknown number. So for example, if we had x times x times x times x, what this means is we have some number, we don't know what it is, multiplied together 4 times. The rules for writing things is the same with variables as it is with numbers. So if I were to tell you to write this with exponents, you could write this as x to the 4th power, because we have some number, x, multiplied 4 times. So this would be x to the 4th power. So x could be anything, right? It could be 3 times 3 times 3 times 3. Doesn't matter what it is. Whatever it is, we raise it to the 4th power, because there's 4 of them. So here are a few other examples. We have 5 squared, and you're to write in factored form. Well, to write in factored form, we have 2 5's, so we do 5 times 5, and that would be in factored form. Here we have a variable, so b to the 6th power. We could write that as 6 b's multiplied together, which would be right there. 2 to the 3rd power, or 2 cubed, we have 3 2's multiplied together, so 2 times 2 times 2. 4 to the 5th power means we have 5 4's multiplied together, so 4 times 4 times 4 times 4 times 4. So make sure you know how to write, even with variables, in factored form or exponential form. Okay, here we have some expressions that you are to simplify. We have 2 to the 4th power plus 3 cubed. So when you're simplifying, you always do the exponents before you add or do anything else. So here, 2 to the 4th power would be 2 times 2 times 2 times 2, which that would equal 16. And then 3 cubed would be 3 times 3 times 3, which is 27. So we have 16 plus 27, which would equal 43. So my simplified answer is 43. Okay, here's another example. So we have 4 squared, and then we have times 3 squared minus 2 cubed. So 4 squared is 4 times 4, which is 16. 3 squared is 3 times 3, which is 9. 2 cubed is 2 times 2 times 2, which is 8. All right, so you want to do parentheses before you multiply. We do what's called order of operations. So parentheses comes first before multiplication. So 9 minus 8 would be 1. So 16 times 1. So remember, parentheses means multiply. So 16 times 1 is 16. So my solution is 16. And we see that typed up in the notes right here. Next we have 5 squared times 2 squared divided by 10. 5 squared is 5 times 5, which is 25. 2 squared is 2 times 2, which is 4. So we have 25 times 4 divided by 10. Do parentheses first. 25 times 4 is 100. And then 100 divided by 10 is 10. Here's another example. We have 15 to the 1st power times 22 to the 0 power. So 15 to the 1st power is just 15. 22 to the 0 power, anything to the 0 power is 1. So we have 15 times 1, which would equal 15. Now lastly, we can write numbers in what's called expanded form. which is using exponents in here. So for example, we have 236.15. So we've learned in the past that you can break apart this number where we have the hundreds place. So this would be looking right here, that 2 represents 200. This 3 is in the tens place, so that 3 represents 30. The 6 is in the ones place, so that 6 would be 6 ones, or 6. And then this 1 right here after the decimal point is 1/10, or 0.1. And the 5 is in the hundreds place, so this would be 5 100ths, or 0.05. So this is in, I guess, partial expanded form. So from here, 200 is in the hundreds place, right? So we have 2 times 100. So we have 2 100s. And for 30, we have 3 tens. For the 6, we have 6 ones. So 6 times 1. For 0.1, we have 1 1/10. So 1 times 1/10. And here, the 5, we have 5 100ths. So 5 times 1 100th. Okay, so lastly, we can write each of these factors of 10, or multiples of 10, with exponents. So 100 is 10 times 10, which can be written as 10 squared. This 10 here is just 110, so that's 10 to the first power. And keeping the pattern going with the tens. See, we have an exponent of 2, and we have 1. So this next one, if we write this as 6 times 10 to the 0 power, that would be another way of writing this 1. Because remember, anything to the 0 power is 1. And I write it like this to keep the pattern going of the exponents. So 2, 1, 0. So then here, 1 times 1/10. The 10 we can write as 10 to the first power. So we have 1 over 10 to the first power. And then 1 over 100. 100 is 10 squared. So I can write that as 1 over 10 squared. So this would be a good answer for writing in expanded form. And don't forget the plus sign in between. And then if you want to get fancy and write this with negative exponents, these first three would be the same, but these fractions, this 1 over 10 to the first power, that is the same thing as 10 to the negative first power. And then 1 over 10 squared is the same thing as 10 to the negative second power. So you could write this with negative exponents as well. And notice that the pattern with the exponents is decreasing by 1. So we have 2, then 1, then 0, then -1, then -2. Now lastly, make sure you know how to convert the other way. So here we went from writing a number into expanded form. Next we're going to take a number from expanded form and write back as a regular number, which we can call that standard form. So here, for example, we have this expression, and we're going to write this in standard form. There are different ways you can think through this, but one way is here we have 10 to the 4th power, which means 10 times 10 times 10 times 10. If you multiply those together, we get 10,000. All right. And a way we can think through this as well is when you're multiplying by tens, the exponent here is 4. That means we're multiplying 4 times. That means we're going to have 4 zeros after the 1. So 1, 2, 3, 4 zeros after the 1. That gives us 10,000. And then here for the next one, we have 4 times 10 squared is 10 times 10, or 100. So again, the exponent is 2. We have 2 zeros after the 1. And then for the next one, we have 6 times 10 to the 0 power. Anything to the 0 power is 1. So we have 6 times 1. And then here we have 1 times 1 over 10, because 10 is the same thing as 10 to the first power. And then lastly, we have 2 times 1 over 100. Right, 10 squared is 100. So this is my first thing I can do when working to write in standard form. And now from here we can try to simplify. So 5 times 10,000 is 50,000. And then 4 times 100 is 400. 6 times 1 is 6. 1 times 1/10. 1/10 is 0.1, right? So we have 1 1/10 or 0.1. And then here we have 2 times 1 over 100. That'd be 2 100ths or 0.02 as a decimal. So from here, just put it together. 50,000 plus 400 plus 6. We get 50,406. And in the decimals, we have 0.1 and 0.02. That gives us 0.12 when I put them together. So this here is my final answer in standard form. And this is just one way to think through this. You could get good at this and skip these middle steps and just realize that 5 times 10 to the 4th means you have 5 with 4 zeros after. 4 times 10 squared means we have 4 and then 2 zeros after because of the squared. Here we have 6 with 0 zeros after, which would just be a 6. And then 1/10, that would be 0.1. And then here 2 times 1/100th is 0.02. And that would also give you the same thing, where you have 50,406.12. And that concludes our lesson for today. We will see you next time.